This is Academic Decathlon Mathematics subject. Worksheet number 4. We are going to jump real quick, very quickly into a way more complex and complicated process. The warm-up problems are okay. This is what two numbers have a product of 24 and a sum of -14. So when we have two numbers, we have two unknowns. We have x and y. X is first number. Y is the second number. So when we have a product, what two numbers have a product of 24? So x times y equals 24. And a sum of -14. X plus y equals -14. So we have two unknowns. So what we want to do is we want to use the substitution method. So we're going to isolate this bottom equation. Well, let's isolate for x just for fun purposes. So this equation is now x equals -y minus 14. And what we're going to do is we're going to take this statement and substitute it in for x. So where we see x, we're going to put negative. So this equation now, instead of writing x, we're going to write -y minus 14 times y equals 24. And now we will distribute, so that's -y squared minus 14y equals 24. We're going to set it equal to 0, so we will add y squared. We'll add 14y to both sides, which sets up an equation 0 equals y squared plus 14y plus 24. And at this point, we need to factor. Now factor. We're going to find the zeros. So we want to take this, we want to factor it, we want to turn it into two binomials, and the signs are the same, both are positives, and the sum of two digits that multiply to 24 that add up to 14 are going to be 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's it. And 2 and 12. So 2, 12, and that's through years and years of experience. We're not going to necessarily use that example, but now we know that in order for something to multiply to equal 0, one of these must be equal to 0. So what value for y would make this 0? A -2. And what value for y would make this 0 is -12. So what two numbers, when multiplied, equal 24? -2 times -12 is equal to 24. And when added, equal -14. So my numbers are -12 and -2. Those are the answers. It's somewhat complex. What numbers have a product of -60 and the sum of -11? So we again, hold on, my wife is calling. Custom, I'm making a video. Can I call you in a couple minutes? Sorry. Hopefully it's good news for my wife. Sorry about that. So two numbers have a product. X times y equals -60. And hold on. Okay. Okay, everything's okay. Yep, not a problem. X times y equals -60. Sorry about that. And the sum x plus y equals -11. So we again are going to solve for one of them. What did we solve for? We solved for x in this one. Let's solve for y. Let's do it differently. So we'll isolate y. We'll minus x. We get y equals negative x minus 11. So we'll take this value and substitute it in for y in the other equation. So where we see y, we're going to, instead of, that says x, instead of saying y, we're going to do negative x minus 11 equals negative 60. We will distribute. That's negative x squared minus 11x equals negative 60. We always want our our leading term to be positive. So that's why I didn't move the 60 over, because our leading exponent, our leading term would have a negative coefficient. So we're going to move everything to the other side, to the right side. And you'll notice that, and we set it equal to 0 because we're going to use the 0 property. We saw that we leveraged the fact that two numbers multiply to 0. We're going to factor. This time, our signs are going to be different. And they're going to be different because that's the only way you can get a negative in this third term. So we need factors of 60. One's going to be positive, one's going to be negative. Factors of 60 when subtracted equal 11. So we have 1 and 60, 2 and 30, 3 and 20, 4 and 15. And if we subtract them, that equals 11. So it's going to be 4 and 15. And I need that my inside and outside, so the bigger is going to be positive. So 15 is going to be positive, 4 is going to be negative. Now again, this product is going to equal 0, so one of these must be equal to 0. So what value for x would make this 0? X would need to equal 4. And what value for x would make this 0? X would need to equal negative 15. So those are my two x values. Oh, that was interesting. I didn't do that very well. I did a really poor job. That was actually really bad of Mr. Mac to just make the assumption. Those are my y values. So that doesn't tell me which one is which. So if I plug in negative 2, I get a negative 12 for x. So there are going to be pairs. So two numbers, right? Sorry. And then if we plug in negative 12, that's going to be a negative 2, because that makes positive 12 and negative 4. So we plug those in for y. Those are my y values. Y equals this, or y equals this. When y equals negative 12, then when y equals negative 2, my x value equals negative 12. When my y value equals negative 12, my x value equals negative 2. Sorry about that. So when we plug it back into here, we have two situations. So y equals, when x equals negative 4, when x equals 4, we plug it in, y is going to equal negative 15. So 4, negative 15, and then when x equals negative 15, y is going to equal 4. But those are still my two numbers. So my two numbers are going to be negative 15 and 4. And when I add them, it equals negative 11. When I multiply it, it equals negative 60. These are just the warm-ups. What number, when added, would make a perfect square trinomial? So a perfect square trinomial, we call that a binomial square. That's an S, not an E. Binomial square has 4 terms, or 4 characteristics. First of all, it's 3 terms. The third term is positive. My first and third are going to be perfect squares, and my middle is going to be equal to 2 times the square root of the first times the square root of the last. Okay, so what value, what constant is going to be here to make this a binomial square? So we take half and square it is how we do this. We take this b value, we take half of it, and then square it. So half of 12 is, excuse me, half of 12 squared is 6 squared, which is 36. So that's going to be my C value. So x squared plus 12x plus 36 would create a binomial square. And we like that. So that's a binomial square. That's called completing the square. So you always take half of your b value, and it's ax squared plus bx plus c is how quadratic equations or quadratic expressions are written. And so this is my a, this is my b, and my c. And whenever we complete the square, a must be 1, which it is in this case. So we take half, square it, and that would be the constant that we would need in order to make a binomial square. That's really what they're asking. What number when added would make a perfect square trinomial? So we take a is 1, so that's good. We're going to take half of 2/3, which is going to be 1/3. No, half divided by 2. 2/3 divided by 2, which is 2/3 times 1/2. Yeah, 1/3. Yeah, take half of it. Yeah, I don't know why I didn't think. So we take half of 2/3 square, which is 1/3. That looks like a cube. We're squaring. 1/3 squared is 1/9. And so y squared plus 2/3 y plus 1/9 would be our, and then we get y plus 1/3 quantity squared would be our binomial. This would produce this. Yes. Oh yeah, that's good. That is so good. All right, find the zeros of the quadratics by factoring. So we want factors of 20 when added equal 9. So x plus 4, x plus 5, and yes, you should be able to mental math that. You've done it so many times that you can see it, especially when your a value is 1. You should be able to see what binomials produce this trinomial, and that's through practice. So what are my zeros? So what value for x makes this 0? X equals -4. What value for x would make this term 0? X equals -5. So those are my zeros, -5, -4. Yep. All right, this is a binomial square, or this is the difference of squares, excuse me. Difference of squares. So difference of squares has three characteristics. It is 2 terms, always 2 terms. It's going to be subtraction between the two, and both terms are perfect squares. So that's a perfect square. This is a perfect square. If it is, it's going to create conjugates. Creates conjugates. Conjugates. Let's get that arrow. So we take, that's going to produce this, and square root is going to be 2y. 2y is going to be your first. Square root is going to be 10. And then conjugates are one's positive, one's negative. And so now what value for y would make this 0? Well, y would need to equal -5, and y would need to equal 5. 5 is 10, 10 minus 10 is 0, so my answer is -5, 5, or in high school they would say plus or minus 5. Okay, so that's the difference of squares. Here we go again. This is pretty good. This is a binomial square. How do I know it's a binomial square? It has 3 terms. The third term is positive. The first and third terms are perfect squares, and the middle equals 2 times the square root of the first times the square root of the last. So my middle term equals the square root x, the square root 3 doubled equals 6. So I know that it's going to be a binomial square. So if I take the square root of x squared, take the square root of 9, and I'm going to bring down this term, and that's technically this. So we can still look at the 0 property of multiplication. So what value for x would make this 0? X equals 3, and that's the same term also. So I only have one 0. Okay, factors of 48 when subtracted equal -8. So we have 1, 48, 2 and 24, 3 and 16, 4 and 12, 5, 6 times 8 is 48. We're subtracting equal 8 right here. This is 8, -8. So my bigger of the two is going to get the negative. So I have t and t. And I have 4 and 12, and I need it to equal a negative. So that's this. What value for t equals 0? T equals negative, that's a horrible -4. Well, let's go back to that eraser. Equals -4, and t equals 12. So my zeros are -4 and 12. Ooh, okay. Now my a value is not 1. So I'm gonna teach you real quick. A times c. A is 21. C is -10. That gives me -210. So a times c. And now we're going to find the factors of -210 when subtracted equal 1. So factors are going to be a lot. 1 and 210. 2 and 105, 3 and 70, 4 no, 5, yes, 5, 5 goes into that 42 times 6, yep, 6 and 35, 7, yep, 7 and 30, 8, no, 9, no, 10, yes, 10 and 21, 11, no, 12, 12, no, 13, no, 14, 14, yes, 14 and 15, hey. So when we subtract those, that equals 1. So, and the bigger is going to be positive. So now, this is the hard part. So this is where it's different. This is where I'm going to take these two terms and I'm going to make this. I'm going to write 21x squared minus 14x plus 15x minus 10 equals 0. This is the a times c. If you want to watch this, if you want to learn this, go to my videos. So now all I did was I took these two terms, because if we add them, it still becomes this. So I haven't changed this left side. I just broke this into two terms. I didn't pick any two terms. I picked these two terms. That's where I got those numbers from. So I'm going to factor by grouping. I'm going to take the first two terms and the second two terms, and I'm going to look for a common factor. What is a common factor between these? 7x. So if I factor out a 7x, I get 3x minus 2. We're okay with that, right? Look at the coefficients, 7. Look at the variables, x. Factor out a 7x, you get 3x. Factor out a 7x, you get -2. Now I'm going to look for a common factor between these two, and that's 5. So if I factor out a 5, I get 3x minus 2. And these must be the same. Must be the same. When they are the same, I know I did it right. So I'm going to take that. They have a common factor of 3x minus 2. If I take those out, if I remove them, what am I left with? I'm left with 7x plus 5. And now I have factored this trinomial into two binomials. Now we have two things multiplying equals 0. What value for x would make this 0? Well, that would be, we could write it like this. We could think about it, or we can just write it and solve for it. So if x equals 2/3, that would be equal to 0. 2/3 times 3, the 3's cancel. 2 minus 2 is 0. And then we do the same thing over here. We're saying, hey, what value for x when multiplied by 7 added to 5 equals 0? 0 equals, so 7x equals -5, divide by 7, divide by 7, x equals -5/7. So my solution is -5/7, comma, 2/3. Those are my zeros. Pretty cool. Way more complex. Again, now I'm looking, hey, I see 3 terms. I see the third term is positive. I see that first and third are perfect squares. And now I'm going to see if I take the square root, and double, does it equal this? So 36x squared, the square root of that is going to be 6x. 9 is going to be 3. If I multiply these and double, that's 18x double. Does that equal 36? Yeah. So this is a binomial square. So I know that it's going to be a binomial square. So I take the square root of this first term, I take the square root of this, and then I bring down this sign. Okay, so remember, this is just like this. And now what value for x makes this 0 would be -1/2. And that would be the same value. So my answer is -1/2. That was pretty fast. All right, not perfect square, not a binomial square, so we're going to use, and a is more than 1, so we're going to use a times c, where a is 2, c is -15. That makes -30. Factors of 30 are 1 and 30, 2 and 15, 3 and 10, 4 no, 5 yes, 5 and 6. I'm going to subtract to make -7. That's that. So I know that it's 3 and -10, so 2x squared. I'm going to change my middle term to these two terms. So that's going to be positive 3x minus 10x. That combines back to make that. Minus 15 equals 0. Now we're going to factor by grouping. And we're going to factor out what's the common factor is just an x. So I get 2x plus 3. What's the common factor? First term is negative, so I have to factor out a -5, which is 2x plus 3. Did I do it correctly? Yes, these have to be the same. So we're going to pull that 2x plus 3, what they have the same out, and we're left with x minus 5 equals 0. What value for x makes this? That's going to be -3/2. What value? X equals 5. So those are my two solutions. -3/2, comma, 5 are my zeros. Those are the solutions to this. Pretty good. Hopefully you're getting better at this. Let's do a times c. So a is 3, c is -8, -24. Factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Signs are different. Bigger is negative. So that gives me my -2. So 3x squared plus 4x minus 6x minus 8 equals 0. Factor by grouping, we'll factor out an x. 3x plus 4. First term is negative. Let's factor out a -2. We get 3x plus 4 equals 0. I did it correctly. I'm going to pull out that 3x plus 4, and I'm left with x minus 2 equals 0. That's going to be x is going to equal negative 4/3, and x is going to equal 2. Negative 4/3, 2. And if you can do this quickly, you know that you're in the right place. All right, complete the square. So we have these two terms. And so what we want to do is we want to find out what is that C value. What is that C value that would make this a binomial square? Well, we're going to take half of the B value. First of all, is A1? Yes. So we take half of the B value, which is 1, and square it. So we're going to add 1. Now, we just can't add 1 to an equation. We would need to also add 1 to the other side. So I know that this is now a binomial square. And that is the square root of this, square root of this. This sign comes down and it's a binomial square, equals 25. All right, so the easiest way, the reason why we complete the square, then solve for the zeros, is we can take the square root of both sides now. Yeah, that's nice. Square root of this is going to be x plus 1, square and the square root cancel. Square root of 25 is going to be plus or minus 5. And now we subtract 1, we get x equals negative 1 plus or minus 5. So we have to do negative 1 plus 5, and we have to do negative 1 minus 5. That's going to be 4, this is going to be negative 6, and those are my two solutions. Yes, pretty good, right? Again, really efficient. Okay, so we have this. We want to add our constant. What value? Take half and square. Half is negative 3, squared is a positive 9. And we have to add 9 to both sides. This is going to create minus 3 squared. We take the square root of x squared. We take the square root of 9. This sign has to come down. And this gives us 121. We're going to take the square root of both sides. And we get x minus 3 equals plus or minus 11. We're going to add 3 to both sides. X equals 3 plus or minus 11. So we have 3 plus 11, and we have 3 minus 11. That's going to give us 14. That's going to give us negative 8. Negative 8? Yeah. So our answer is negative 8, 14. Those are the two solutions. Oof. All right, first thing we see is that A is not 1. So what do we multiply to get rid of, to make A 1? What times 1/2 is going to make that 1? If we multiply by 2. And we would have to multiply everything by 2. So that would make it x squared plus 14x equals 15. And now we want that value. What value of C would make this a binomial square? So we take half and square it, which is 49. And we would need to add 49 to both sides. So this becomes x plus 7 quantity squared. Square root, bring down that sign. And that's going to be 64. We'll take the square root of both sides. X plus 7 equals plus or minus 8. Let's minus 7. X equals negative 7 plus or minus 8. So negative 7 plus 8 and negative 7 minus 8, which is 1. Negative 15. So my solutions are negative 15, 1. Same thing, we got to get rid of this. This time, what makes this is by dividing by 4. So we have to divide everything by 4. So that becomes x squared. That becomes 1/2 x equals 3.75 divided by 4. I kind of want a fraction. I don't like decimals. So 3 3/4 is 12 15/4. 12 15/4. And if we divide by 4, which is like multiplying by 1/4, which is 15/16. Okay, 15/16. Now, let's find that value. Let's take half of that and square it. Half of it is 1/4. Squaring 1/4 is 1/16. So we're going to add 1/16 to both sides. And this gives you x plus 1/4. Remember, it's a square root, quantity squared. And this is going to give me 1. 15/16 plus 1/16 is 16/16, or 1. And now we take the square root. We get x plus 1/4 equals plus or minus 1. Let's subtract 1/4. And that gives me x equals negative 1/4 plus or minus 1. So negative 1/4 plus 1, negative 1/4 minus 1. That gives us 3/4, and this gives us negative 5/4. So negative 5/4, comma, 3/4. Oh yeah, such a good problem. I love it. That was such a good worksheet. Boom. Yeah, you can do that. You are good to go. So all of this stuff can be found on my my YouTube page. If you want to see factoring, finding zeros, I have 10, 20 videos showing you how to factor A times C, factoring binomial squares, factoring difference of squares. Take a look. You're going to have to put some time into it. We won't get to this until February, March, later on this year. So academic decathlon requires you to do a little independent learning. Mr. Mack teaches you A times C. I would do this too. I would sort of see how these binomials. So if you look at this, if you multiply each of these out, these different iterations of the same problem, and then you'll see how things are manipulated, how that middle term, this is x squared plus 9x plus 20. This is going to be x squared minus x minus 20. This is going to be x squared plus x minus 20. And this is going to be x squared minus 9x plus 20. Oh, let's take a peek. Okay, notice when this third term is positive, the only way, because this last term is the product of these two. So what do we notice? How do we get a positive? Because you have a positive times a positive equals a positive, or a negative times a negative equals a positive. So we know my signs are going to be the same. Signs are the same when this is positive. What happens? How did we get negative 20? Well, we multiplied, the signs were different. We multiplied a positive 4 times a negative 5. That's the only way. This is always going to be a product of something. And this is the sum of two things. Remember, it's FOIL. First, outside plus inside, and last. Last is a product, first is a product. This middle term is a sum of two products. So how do we get positive 9? Well, you have positive 5 and positive 4 equals positive 9. And you have negative 4 and negative 5 equals negative 9. So the sum of these two equals the middle term. The product of these two equals the last term. And then we can see that. Positive 4, negative 5 is negative x, negative 1. So when the signs are different and we have a negative middle, we know that the bigger of the two has to be negative. So, and that's just when this is 1. Okay, so we have to be careful. This trick only works when it's 1. When it's not 1, then we have to learn A times C. All right, good luck.